This video will describe the properties of substances that contain metallic bonds. So for ionic bonds, we have those really rigid crystal structures that are created. Molecular bonds lead to a lot of variety. Metallic bonds are very unique in themselves, right? In that they give those properties of conductivity and malleability. And the reason behind all of those phenomena is that sea of electrons, okay? So structurally, metallic bonds tend to lead to crystalline structures similar to ionic compounds, where they make those nice uniform patterns. But unlike ionic bonds, because of the sea of electrons and the fact that the electrons are not held tightly by any one given atom, the crystal structure is not considered rigid, but rather it's considered very flexible. Again, the reason is because since there's some room between each adjacent nuclei as the electrons are flowing, there's flexibility within the structure. That leads to the property of conductivity. So conductivity is the ability of having charged particles moving or flowing. And since the electrons are not tightly bound, they are able to move, and thus all metals are able to conduct electricity when they're solids because they have those point charges that can move. Also, because of this flexibility and those sea of electrons, metals are very malleable and ductile. Those words mean, while it's a crystal structure, when you strike a metallic substance with a hammer, generally you will dent it or bend it, rather than for ionic compounds, when you strike it with a hammer, you will break it. Okay, that's malleable. So that flexibility that metals have to be able to bend has to do with the fact that, again, you have this area, because of the sea of electrons, that allow for compression. Metals are also ductile. So ductile means you can take metals and draw them out into, for example, wire. So ductility to me, oftentimes what I'm picturing is silly putty. The fact that you can take silly putty and like draw it out, and as long as you do it slowly, it doesn't break. That is ductile, and metals tend to be ductile because there's a lot of space within its crystal structure to allow for substances to move around. Opposed to, again, if you applied pressure to an ionic substance and tried to stretch it, the crystal structure would simply shatter versus allow it to be drawn out into a line. Typically, when we think about the property of like melting and boiling, ionic compounds have our highest melting point and covalent compounds have our lowest. Metallic are somewhere between. We think of them having lower than ionic, but in general, they're still pretty high in comparison. Another property of that metallic bond is that they can make alloys, which in class we will be doing the penny alloy lab. And essentially, because of the flexibility within the structure, because of the sea of electrons, metals are more easily able than lots of other things to mix together in such a way, like replace each other essentially. So iron being bonded to itself in a metallic bond could just as easily be bonded like iron and another metal, and it would structurally the bond would be just as good. Okay. The reason we might want to do that is because we change the properties of the compound because of having a mixture, but metallically you're still bonded the same way in an alloy. That's all there is about the properties due to the sea of electrons. Have a nice night.